Yes, good morning. Today we're going to talk about section 5.3 entitled Polynomials and Polynomial Functions. Basically today we're going to define polynomials. Despite working with polynomials for many years, often students have no idea how to define what a polynomial is. We'll talk about that today. Then we'll talk about evaluating polynomial functions. And introducing function notation in the context of polynomial expressions, and then adding and subtracting polynomials, which is nothing more than nothing more than adding like terms, as we'll see. Add and subtract polys. Polys is my abbreviation for polynomials. Alright, let's start with defining what a polynomial is. Well, of course, the Greek prefix poly means many, and well, let's talk about what it means to be a polynomial. Well, the first thing I want to talk about in defining is a monomial. Mono means one. Right? A monomial is nothing more than a product of powers, could be more than one, powers of variables, and again there could be more than one, and constants. Alright, so if I write down 3x squared, I call this a monomial. It's a monomial because it's a product of powers of variables and a constant. Minus 4xy cubed is a monomial. There's more than one variable, more than one variable, but it's again a product of powers of variables and constants. If I write 2/5 ab squared c cubed, that is also a monomial, because it is a product of powers of variables and constants. Let's talk about what it means to be a degree. If I look at 3x squared, I claim that is a monomial of degree 2. Now, if a monomial has only one variable in it, the degree is just that single exponent. Okay, so a monomial of degree 2, 3x squared, monomial of degree 2. Minus 4x cubed, minus 4xy cubed. I claim this is a monomial of degree 4. If there's more than one variable, you add up the exponents on all the variables. Now remember, x has an invisible exponent of 1, so if I add those exponents, the implied 1 plus 3 gives me 4. So minus 4xy cubed, monomial of degree 4. Let's see, 2/5 ab squared c cubed. This is also a monomial of degree, let's see, 3, 4, 5. A is just a to the first power, so that's degree 6. How about I write something, well, let's say like 7. 7 is also a monomial. You may say there's no variables, there's no powers of variables, but I could write it as 7 times x to the 0 power, could we not? Alright, so then I can clearly see a constant is also a monomial of degree 0. So all constants are degree 0 monomials. Let me write that down. Any constant is a monomial of degree 0. Okay. Alright, so we've defined what monomials are and how to define and characterize their degree. Now I'm ready to define what a polynomial is. Now again, poly means many. A polynomial is nothing more than a sum or a difference of monomials. So once I define monomials, I can easily then define polynomials. 2x plus 5. This is a binomial. It's a binomial. Bi means two, right? It's a binomial because it's a sum of two monomials. Now let's talk about the degree of a polynomial. What's the degree of 2x plus 5? Well, the degree of a polynomial is the degree of the highest degree monomial that it contains. Alright, so the 5, of course, has degree 0. 2x has degree 1. So I claim then this binomial is degree 1. Let me write that down. The degree of a polynomial is the degree of the highest degree monomial it contains or contained therein. Okay? Alright, let's look at some more complicated examples of polynomials. Let's see. Try minus 17 thirds minus 17 thirds. Alright, I'm having trouble here. The screen is getting jittery. Bear with me. Minus 17 thirds times x to the 4th power minus 3/5 x to the 3rd power. Alright, I call this a binomial. Why binomial? Because it's a sum or difference of two monomials. So what's the degree? Well, the degree of a polynomial is the degree of the highest degree monomial it contains. This monomial is degree 4. This monomial here, I'm sorry, hang on a minute. This monomial is degree 3. This monomial is degree 4. So overall, the polynomial has degree 4, the degree of the highest degree monomial that it contains. Binomial, degree 4. Okay? Let's try another one. Let's do a nasty looking one here. Okay? So if I give you this polynomial, it's a sum of 3 monomials, is it not? So we'll call this a trinomial. And let's characterize it by degree. Well, this monomial has degree 6. This monomial has degree 5, right? We add up the exponents when there's more than one variable. And this monomial has degree 7. So the degree of a polynomial is the degree of the highest degree monomial that it contains. So I call this a trinomial of degree 7. Alright, so we've satisfactorily defined monomials and polynomials and learned how to classify them by degree. I want to talk now about polynomial functions. And hopefully we are familiar with function notation from earlier classes in algebra. Well, a very simple example is something like this. Now, a polynomial is, a polynomial function First of all, it's a function that's assigned a polynomial expression. Alright, so f of x, again, we read this as f of x, not a product, right? Not f times x. F of x, f is a function of x, equals the polynomial 2x plus 1. And typically we use the letters f, g, and h are reserved by convention to symbolize functions. Okay. F, G, and H, and others as well, reserved to define functions or used in function notation. All right, how do we evaluate polynomial functions? Yeah, let's say, keep that same first example. If f of x is 2x plus 1, let's say I ask you to evaluate f at minus 2. Well, all that means, all that's in parentheses here is a placeholder. All that means is wherever I see an x in that polynomial expression, I plug in a minus 2. Of course, 2 times minus 2 is minus 4, and minus 4 plus 1 is minus 3. Give you another function here. Let's try another one. G of x is minus 1/2 x minus 1. Let's say I want you to evaluate g of x at the following points. Well, let's try g of minus 2. Again, the parentheses expression is a placeholder, really. And everywhere I see x in that polynomial function, I plug in a minus 2 and grind out a number according to my order of operations. So minus 1/2 times minus 2 is of course positive 1, and positive 1 minus 1 is 0. So g of minus 2 in this example equals 0. Let's try something a little harder. We're going to get a fresh screen here. Let's define a function in terms of h. So I say h of x equals alright. Now once we go, alright, binomials are sums of 2 monomials, trinomials are sums of 3 monomials. When I go beyond 3, basically I cite the number of terms. I don't call them quadromials or anything like that. I'll call this a 4-term polynomial of degree, well, you tell me. Degree what? Well, the highest degree monomial this polynomial contains is degree 3. So I claim that is the degree of the polynomial. Okay? Alright, for this polynomial, let's say we ask you to evaluate the polynomial at minus 1. In other words, evaluate h of minus 1. Now be careful about the signs here. Everywhere I see x in that polynomial expression, I plug in a minus 1. And then perform my calculations based on my order of operations. Minus 1 cubed is negative 1. Minus 3 times minus 1 squared is 3. Minus 9 times minus 1 is minus 9. Plus 2. Alright, I can add these up now. Well, minus 1, let me combine these negative signs here. Negative, negative is positive. So I get minus 1, minus 3, plus 9, plus 2, and that reduces to, let's see, 5 plus 2 is 7. So h of minus 1 is 7 in this case. Alright, so we've talked about defining polynomials, we talked about evaluating polynomial functions. Now I want to talk about adding and subtracting polynomials. and really not such a big deal. I'm sure you all know how to add and subtract polynomials. And basically just involves combining like terms. Let's say I've got two trinomials. I've got a trinomial of degree 2, and to that I'm adding another trinomial of degree 2. Alright, how do I add? Basically I add the like terms together. 2x squared and 5x squared, those are like terms, and combine to 7x squared. Similarly, minus 3x plus positive 4x gives me a positive 1x, or just x, and then plus 5 plus minus 2 gives me a 3. Alright, so to add polynomials, essentially we combine like terms where we can. Let's talk about subtracting polynomials. Let's see. Let's say I start out with 8x cubed plus 2x squared. That is a binomial of degree 3. To that, or from that, I'm going to subtract 4x squared minus 3x. This is a binomial of degree 2. Alright, well, when I'm negating a sum or a difference, you've got to change the sign, basically carry this negative sign through in order to drop those parentheses so I can combine like terms. So let me do that. I will carry that negative sign through, changing the sign of all terms in the polynomial I'm subtracting. And now I can look to combine some like terms. 8x cubed. Notice there are no other degree 3 terms in this polynomial. So I'll keep 8x cubed by itself. Doesn't combine with anything. Alright, 2x squared minus 4x squared. These are like terms. The variables are the same, the exponents are the same, the coefficients are perhaps different. Well, I'll just now subtract the coefficients and keep the same variable part. And 3x, again, doesn't combine with anything else. So I combine when I can and end up with the result 8x cubed minus 2x squared plus 3x. Let's do something a little harder. Add the following two polynomials. Now, don't panic. Sometimes we've got to deal with fractions. Alright, so I claim this is a polynomial, a binomial of degree 4. To that, I'm going to add a binomial of degree 4. Alright, so clearly I can combine some terms here. I can essentially drop these parentheses and add the like terms. Well, I'll add the degree 4 terms. I'll add the m to the 4th terms. And similarly, I'll combine the degree 3 terms, the m cubed terms. Okay. Now, once you've identified like terms, of course, we can just add or subtract the coefficients as indicated and keep the variable portion. Well, 1/4 plus 3/4 is 4/4. Well, that's just 1. So adding these two like terms, I get 1m to the 4th, which is just m to the 4th simply. Similarly here, adding the m cubed terms, I get 1/2 minus 7/3. Well, let me do a little side work here. You'll need a common denominator to add these fractions. I'll multiply top and bottom here by 3. And multiply top and bottom here by 2. So I end up with 3/6 minus 14/6, which gives me a negative 11/6 as my coefficient. So when I combine those like terms, I get minus 11/6 times m cubed. So a little nastier, but nothing we shouldn't be able to handle as long as we perform our arithmetic correctly. Alright, I want to do one similar to this from our homework list. This is number 53 on page 431. And again, it's probably reflects the upper limit of difficulty in this section. And all these involve fractions, so hang on. That is a trinomial of degree 3. And from that, I'm going to subtract another trinomial of degree 3. Alright, so if we can handle our fraction arithmetic and keep an eye on like terms, we should be able to handle this without too much trouble. Alright, I'm going to let me go ahead and rewrite this. I'm going to rewrite this first trinomial. Nothing's going on outside these parentheses, so I can essentially drop these parentheses. Now to drop these parentheses here, I'm going to have to distribute that negative sign through, carry that through all terms in that second trinomial. In other words, change the sign of all the terms. Let me check it. Minus 1/3 w cubed, minus 1/3 w cubed plus 1/2, I'm sorry, yes, minus 1/2 w squared, and negative of a negative is positive 1/5. Alright, so the degree 3 terms will be able to combine, the w squared terms will be able to combine, and of course the constant terms will be able to combine. Let me scroll down here. 5/2 w cubed minus 1/3 w cubed. Well, let me do a little side work here. 5/2 minus 1/3. If I get a common denominator here, I'll get 15/6 minus 2/6 will give me 13/6. So combining this degree 3 term with this degree 3 term, I get 13/6 times w to the third power. And once I've combined them, I like to strike them out so I don't get confused. Next, I'll combine the degree 2 terms. Well, this I think we can do in our heads. 1/4 minus 1/2. Well, maybe not. Let's write it out. If I add or subtract those coefficients as indicated, 1/4 minus 1/2. Well, 1/4 minus 1/2 is 2/4, and 1/4 minus 2/4 is minus 1/4. So I'll get a w squared with a coefficient of negative 1/4. Takes care of the degree 2 terms. And now 3/5 plus 1/5, of course, that's going to be 4/5. So combining like terms and performing our fraction arithmetic, we get that return. Alright, that's it for section 5.3, a pretty easy section. Things will get tougher later on in chapter 5. But we'll call it a day here. We're reaching the 24-minute point, so please review all materials, in particular complete all homework problems and check them with the Homework Solutions PDF file before you attempt the 5.3 online exam. That's it for today.